Alright, so we are gonna be starting quantum physics, and in this video we're gonna be looking over the energy and momentum of photon. We're gonna be covering all these five objectives. So let's get started. We're gonna be kicking things off with the quantum theory. Now, what's the quantum theory? Well, this chapter basically proposes the idea that electromagnetic radiation is not just a wave, but it also has uh, a particulate nature. Now, the particles that make up an electromagnetic radiation are known as photons. So, this is the basic idea of the quantum theory. So, let's just write this down. Electromagnetic radiation isn't just a wave, but it has a particulate nature as well. The particles that make up this are known as photons. So, as you've guessed it, this is going to be our main focus of this topic. Well, not of this topic, but also of this chapter as well. We're just going to be diving really deep into photons. All right. So, this was the quantum theory. Now, we have covered the first objective that electromagnetic radiation has a particular nature as well. And electromagnetic radiation is made up of photons. Now, now let's understand what is a photon. All right. So a photon is basically a small packet of energy, a discrete packet of energy, or also known as a quantum of energy. And an energy of what? Energy of electromagnetic radiation. So meaning that a photon can be a small packet of microwaves, small packet of light, small packet of gamma rays, and so on and so forth. So let's just write this down as well. Quantum or discrete of energy of. All right, so this is a photon. Now let's move on to what makes a photon or the formula of a photon. So since we know that a photon is a small packet of energy of electromagnetic radiation, we're going to be focusing on the formula of the energy of a photon. And the formula of an energy of a photon is given by its energy is equals to hc divided by lambda. Now, let me just label these. Uh, h is our Planck's constant. This is just a constant number. And your c is your speed of light. Oops. C is your speed of light. And lambda, as you may have guessed, is your wavelength of the photon. All right. Yeah, so this is the basic composition of the formula of a photon. And we have another formula for the energy of a photon. And basically that comes from the formula of frequency. So as we know that frequency is basically your v is equals to f lambda. So let me just write that down. V is equals to f lambda is obviously your wave equation that you've studied in your AS. And from here, we're gonna get our V upon lambda. And in this case, our V is the speed of light. So we're gonna be taking F as C upon lambda. And as you may have guessed, you have C over lambda present over here. So we're just gonna be substituting this into the same formula. And hence, we're gonna get E is equals to HF. This is our second formula, basically derived from the first formula. All right, so this is working. I'm just gonna be, I guess, highlighting this a bit. All right, so yeah, this is the second formula, and this covers up the energy of a photon. Now, another uh, energy concept is gonna be relating to the electron volt. Now, since this energy is given in joules, sometimes the energy of a photon is given in electron volts because a photon is so small that its energy is also going to be very small, and its energy is around 1.6 multiplied by 10 power minus 19 joules. And since it's such a small number, we've basically made up a name for it, and its name is the electron volt. So if our photon has an energy of 1.6 multiplied by 10 power minus 19 joules. It's known as the electron volt. And usually the energy of photons are measured in electron volts because it's going to be really redundant to keep on mentioning this very small number. And another usual case of the energy of a photon is that sometimes we may get the electron volt as in a mega electron volt, and mega is just the 10 to the 6 power exponent. So I'm just gonna be writing that down. This is your mega electron volt and its energy in joules. All right, so this was the electron volt. I'm just gonna be adding a header to this. All right, now we're gonna be moving on to the momentum of a photon. Since we know that a photon has mass and obviously has velocity, hence it has momentum because your momentum is made up of mass and velocity. All right. And in terms of energy, we have a formula for this, which is known as energy upon the speed of light. And this energy is your energy of a photon. And this is going to be the speed of light. And all right, so this is the momentum of photons formula. Now you may be guessing that we have P as the momentum of photon, E as the energy of a photon, but why isn't C the speed of a photon? Well, a photon has the speed of light because it's a small packet of energy of electromagnetic radiation, and every electromagnetic radiation has the speed of light. So hence, a photon also has speed of light. So this was the reasoning behind this. and this is the formula for the momentum of a photon. And by this, we can generate another concept by using the first formula that we just ran over, that since E is equals to hc upon lambda, sorry, since E is equals to hc upon lambda, and since P is equals to E upon C, we can just reorganize this and make E upon C the subject. So we are gonna get h upon lambda. We're gonna get h upon lambda, and by this we can see that the momentum of a photon is equal to h upon lambda as well as E upon C. All right, where lambda is the wavelength of a photon. So here we get these concepts, and I can just mention these. So here you get two formulas. Obviously, E upon C being the main one. All right. So this was it for this video. We have covered all the objectives, and I hope you guys understood everything. And yeah, we're gonna be covering the other uh, objectives, other topics in the next video. But just to cover up things, we have understood that electromagnetic radiation also has uh, a particulate nature. We understood what a photon is. We understood its formula, its other formula, and its derivation. We understood what's an electron volt and why it's used. And most importantly, we understood the momentum of a photon. All right. So yeah, this was it for this video, and I'll be covering up the other topics in the next ones.